for today is I'm going to go through these problems. I'm going to go through them I'm going to go through them a couple ways. So originally when we started doing these problems, we factored, and then we set the factors equal to 0. Agree? So we're at the point now that sometimes to factor is faster than faster than the quadratic. Thank you. The quadratic formula. Okay? But how do you know? How do you know? So let's take a look. I'm going to start on number 13 on page 164, and I'm just going to walk through it, okay? And if you feel comfortable with the quadratic, my friends, I'm going to tell you, keep using it. Keep going. Go for it. Okay? But some of you, you might have processed the factoring in a different rate, so let's make sure that we feel comfortable in this case. All right. So if I had this problem, yes, the quadratic formula will indeed work. Quadratic formula works on all of them, not just some of them. It works on all of them, which is great. But I want you to think about something before you go to the quadratic formula if you were doing well with the factoring. Do this. Put a 1 out front and say, okay, I get negative 18. I know I have alternating signs. Is there a way that I could take the factors of 18, one being positive, one being negative, that would add up to 3? What do you think? So let me just list the factors of 18. I got 1 times 18, I got 2 times 9, and I have 3 times 6. Is there a way that I could combine one being positive, one being negative, that would get us to the positive 3? This is joint effort. Yeah. So you have 6x minus 3x. That right there would give us 3x. Agree? So if you factored it, you could just say, oh, okay, well, I know if I do this and this, it's going to work out just fine for you. Okay, you factor the x out, you get x plus 6. You take the negative 3 out. And so basically you get x plus 6 equals 0, and you get x minus 3 equals 0. So I get x equals negative 6, and you get x equals 3. Okay? Now, if you did the quadratic formula, you're going to get x equals negative 3 plus or minus square root 3 squared minus 4ac all over 2a. This would get you the same answers, but a problem that I often have with the quadratic formula is there's potential spam calling me. Sorry about that. Let's delete that. All right. So the problem with the quadratic formula is there's lots of places that sign errors take place. Okay? Meaning you don't get the right answer because you made an arithmetic error on it. Okay? But so, can I move on to number 14? We good? Number 14 looks like this. I get 2x squared plus 5x minus 3 equals 0. So just by looking at it, can you tell if it factors or not? It seems like it might. And all you have to do is just do a quick little test. Okay, I get a negative 6 multiplying the front and the back. I know I have alternating signs. The factors of 6 are 1 and 6 and 2 and 3. Will any of those work when I add and subtract them from each other? That would get me positive 5. What do you think? One has to be positive, one has to be negative, though. Yeah. So this is going to work. if I have positive 6x minus 1x, if I take this and I replace it here, it's going to factor. Okay, and again, this might be a faster way to do it. Might be a little bit faster way to do it when you go through it. So I get 2x minus 1 equals 0 and x plus 3 equals 0. So add 1 to both sides, divide by 2, subtract 3 from both sides. There's my two answers. Okay, now let me just get a little space over here. I'm going to move this over here a little closer. Okay, so let's do this as the quadratic formula too. A equals 2, B equals 5, C equals negative 3. So you know you have x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. So you go through and you do the math. So you get negative 5 plus or minus 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24 over 4. X equals negative 5 plus or minus square root 49 over 4. Square root of 49 is 7. Agree? And then I'm going to go negative 5 plus 7 over 2. So that's going to give me 2 over negative 5 plus 7. Oh. I made a mistake someplace. Negative 5b squared minus 4. That's... Oh, there's my error. Silly old stirrup, can't even do some math. Ooh, hang on. Where are you looking?
At the last part, you wrote it to instead of 4.
Oh, thank you. See? All right, so I get x equals negative 5 plus 7 over 4, so that's going to give me 2 over 4, which is 1/2, which is this answer. And I'm going to get negative 5 minus 7 over 4, so that's going to give me negative 12 over 4, which is negative 3. There's my other answer. But please notice, if we didn't have Jack's keen eye, I wasn't finding my error. Okay? So the quadratic formula, it's great because it works. What's not great is, well, you just saw it. It was easy enough to make a small little error. So if you get to problems that you can factor easily, factor them and solve it, rather than going through the quadratic formula. But if your go-to is always a quadratic, great. I'm not saying don't do it. I'm just saying make sure that if you know how to factor it a little bit, go for it. So let's take a look at number 15. So I have x squared plus 6x equals 0. Hey, what's my c value got to be up here? My a value is 1, my b value is 6, my c value is 0. But this is a pretty simple problem to do. Just factoring it. Okay? If I did the quadratic formula, I mean, to me, that looks like, quick and easy. Quadratic, x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. I've just done more work putting it into the quadratic formula than it was even to finish it out. So yeah, I get negative 6 plus or minus 36, because this whole thing becomes 0, over 2. Negative 6 plus or minus 6, because square root of 36 is 6, over 2. Negative 6 plus 6 is 0. 0, 0 over 2 is 0. Negative 6 minus 6 is negative 12. Negative 12 over 2 is negative 6. So there's my two answers. But again, this was a much faster way to do it. Okay? So, yeah, the quadratic formula is a valuable thing, but sometimes it's going to be more work for you when problems are already kind of handed to you. Can I move to number 16, my friends? Number 16, I have x squared minus 25 equals 0. Okay? Revert back to September in this class. I bet you I have to add 25 to both sides. Root, don't forget the plus minus. Plus or minus 5. This problem's done. My a value on this problem would be 1. My b value is 0. My c value is negative 25. Okay? So, again, that right there on number 16 is a lot shorter method to go through. So how do you decipher which ones are going to work once you're done? It really comes down to practice. Okay? You're going to start seeing patterns. I mean, we're talking about infinite numbers that we have, but we're not using infinite numbers in this class. We're basically saying, oh, we're using perfect squares up to maybe 144, maybe 196 if it was kind of a weird one. But we're trying to keep them at a thing to get you a thought process of going through them. Number 17 looks like this. 3x squared plus x minus 4 equals 0. Some of you might see that could be factored. And I think this is a tougher one, but what's the very first test you would do to see if it could be factored? What do I get there? And in order to get a negative 12, I have a positive and a negative. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Is there a way that one of those sets of factors, one being positive, one being negative, would give me a 1? What do you think? Can I use 1 and 12, one being positive, one being negative, that gives me a 1? No. What about 2 and 6? I can get either 4 or negative 4. 3 and 4 are going to work. Which one has to be positive when I add it together? Yeah, so it's going to be a positive 4 and a negative 3. Okay, again, I can plug this in right here. And I can go just start solving it. So I get 3x plus 4 and x minus 1. So my answer, 3x plus 4 equals 0. Divide by 3. Or x minus 1 equals 0. There's my two answers. Could I have used the quadratic on it? Yeah. And it's still going to come up with the same thing. But again, my friends, the problem is so many people make errors on the quadratic formula because there's a lot of moving parts that are existing in that problem. So you just have to be cautious. Okay, am I going to give you a test that has everything that only the quadratic formula works on? Probably not. But I mean, the main simple test, if I just made up something arbitrary, if you're like, okay, does this factor? Well, I get positive 12. Oh, geez. Let's make that a 17, negative 17. If you went through this and you're like, okay, both have to be negative, and I have 1 and 12, 2 and 6, 3 and 4. Do any of these, this is not one of the problems on there, do any of these wind up working to give me negative 17? No. What do you do at this point? Quadratic formula. Okay? And then the last problem. The reason I wanted to show you the last problem is for the very simple reason, what is my C value? What's my C value up there? Now you're talking about a big number that you're multiplying. 4AC, 4 times A, 4 times 1 times C, 72. That's going to be a big number. So another thing kind of think about in this class, is that number pretty big? Yeah, okay, so let's multiply those together. I get positive 72. Okay, in order for this to be a negative, they both have to be negative, and I know that 8 and 9 would work. And then just plug them in and solve it. But what's the right way to do it? Well, if you're getting the right answer using the quadratic, great. But it's okay if you explore outside saying, you know what, let's go back to this factoring. We did it an awful lot. So that problem looked pretty nasty. And then when you solve it, it looks pretty gentle. But again, the quadratic formula, because your C value is 72, you're talking about a big value that's in there. You have to just guess and check. I mean, the main thing is, what I approach any of these problems doing, and we're going to actually do some whiteboards here in a sec. But, all right, so my friends, what my goal is I want to do this. I want you to try the problem that we do on your whiteboard. And I'll give you, a minute or so to try it. And then we'll correct it, and then you can write it right into your book. Deal? Don't write it into your book right away. Try it on the whiteboard, okay? So try number 1 on page 165. See if you can figure out. And I'm going to tell you this, though, friends. First thing I'm going to do is I'm going to go, hey, I have negative 3 times 1. That gives me negative 3. In order to get a negative number, I need a positive and negative. Is there any way that I can make 1 and 3 add up to 6 if one's positive and one's negative? No.
So what might be the better formula?
Quadratic. It's right there on the top. Top of your page. So x equals negative b plus or minus square. Square minus 4ac. Someone got the squeaky pen. All right, ready to try? So double check. So I've plugged into the quadratic. So I have A is 1, B is 6, C is negative 3. Do you all understand why factoring doesn't work on this one? That primary test where I multiply the last number and the first number together, there was not any factors that added up to the B term. Okay? All right, so if I walk through and I do this, double check how you did it. I'm going to write all the steps down. Negative 4 times 1 is negative 4. Negative 4 times 3 is positive 48. Oh, wait. Whoa. Stir up. Jumping through too many hoops at once. And that's going to give me negative 6 plus or minus root 48 over 2. So over here on the side, root 48. 48's the gotcha one. What's the biggest perfect square that goes into 48? It's the gotcha one. What? 16. Very good. 4 indeed does work, but 4 is not the biggest perfect square. So the square root of 48 is 16 times 3. Again, it's one of those you double check on your calculator. Utilize the tools available. So that's going to give me 4 root 3. So I'm going to replace that with here. And just reduce. So my answer to this is negative 3 plus or minus 2 root 3. Plus or minus means there's two answers. Okay? This is exactly why factoring didn't work, because I came up with a radical as part of my answer. When you're doing these, if you get a radical part of your answer, it means it was not factorable. When it used to be not factorable, we used to call it prime. Now it will indeed solve, but just be cautious. Friends, is there any questions on problem number 1? Do you have it correctly written down now in your book? Anyone need more time to write down the book?
Yeah.
All right. I'll give you to 41.
I'll be right back.
I'll be right here.
Okay, cool.
May I move on? Good? Almost? Yeah. I had all the desks going that way, had this desk and that table over there. Oh, it's right out in the hall. I'm sorry. It did smell. Some of you smelled it more than I did. I had to stick my nose down there. Ooh.
Yeah.
It's like, they were not good. Good? All right. My friends, on your whiteboards, will you please try problem number 3? It's 2x squared plus 3x minus 20 equals 0. So please try this. I get negative 40. In order to get a negative number, one has to be positive, one has to be negative. Factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Do any of those work? One being positive, one being negative, that would add up to our b value, which is 3. Do any of these add up? I'd say no, I'd say no, I say no, I say yay. Try and factor that one without using the quadratic. We got squeaky little mice, it sounds like, with those pens. Okay, as you're kind of starting to double check, some of you might have tried factoring it and said, I'm going right to the quadratic, vice versa. So I'm just going to show you how to factor it. There's my two answers. It factored nicely. Did anyone choose to use the quadratic formula on this? If so, did you get the same answer as I? Cool. But can you see how this one might not have been quicker than using the quadratic formula, but it might have been. So you could write down whatever you need in your workbook for number 3. And if you did the quadratic and you got it right, well, maybe you write that down. But maybe put a little note next to it saying this one would have factored, which is okay. Excuse me. It's going in your head, isn't it? Sorry. Anybody else need more time? Are we good? Carly, good? Need more time? Okay. Good, Rice? Everyone else good? All right. So we're going to take a look at number 5. My friends, number 5, just looking at it, do you feel this would be a quick factorable problem, or are you going to go through the quadratic formula? Do what? It's quick. I have 2 terms. Agree? I have my A term, which is 1. I have my B term, which is -3. What do these both have in common with each other? X. There's my answers. Okay? I would bet you, if you didn't see that trick, the quadratic formula is a lot longer process. Agree? Does anybody need more time writing that down? I'll get a better raindrop for you. I got a hole in the back of my head. That's true. All right, my friends, taking a look at number 7. Write that down on your whiteboard. But does anyone see anything that's kind of a red flag as it sits for us to start working it out? Yeah, it equals 2. It doesn't equal 0. So your first move on this problem, my friends, is subtract 2 from both sides. So that gives you x squared minus 4x minus 2 equals 0. You can try our little trick saying, okay, if I multiply negative 2 times 1, I get negative 2. That means I have 1 positive, 1 negative. 1 and 2 are my only factors. Is there any way that I can add 1 and 2 together where 1's positive, 1's negative, that 1 and 2 would give me negative 4? No. So what do you have to do? Quadratic. So try the quadratic on it, see how you do. But make sure you make your A, B, and C off of it when it's equal to 0, not when it's equal to 2. $11, is that time we're out here? Mm-hmm.
So like what I think about is like, for example, like this one, you can easily so like you see how you factor that one? Now I can start by negative 2 and then you try to factor to make it just you back. So what I would do is try factoring first to see if the factors work. If they don't work, then go into quadratic. I don't know. And I would say also too, like this one like B or C, then we factor easier way, right? So it's just kind of playing it by ear. And really it's just more of like trying to save you more time. But like in this case, like you really want to use the quadratic because you can't factor it. You would have put this as no factor, right? But you can use quadratic. So it's just really honestly like kind of playing around with it. And see. Yeah, it's question again.
There's my answer. Hey, why would that answer, if I got that as an answer, why do I know it won't factor? Because I have a radical as part of the answer. All right, so my friends, your assignment that we'll mark off tomorrow is page 165, 166, and it's going to be 1 through 17 odd. Now, what did we do? We did 1, 3, 5, and 7. We did 4 of them. So now you just have 9, 11, 13, 15. We did 4/5 or 4/9 of the assignment, so you have to do 5/9 of the assignment. Sure,